All right, back in the diagram. Okay. So I believe we were confused about where what IDV is. So let's go ahead and I think we had the here's the paper. La-di-da-di-da. Okay. Da-da-da, da-da-da, da-da-da-da-da, okay, none of this. We don't care about any of this. Not right now, I mean, at least. Um, the wallet sends ask message to identity hubs of each PFI it desires to include as a potential fulfillment counterparty. All right, so Alice's wallet resolves, number one, Onramp example. Alice's wallet resolves and caches the current set of keys and identity hub endpoints for the DIDs of known and discovered PFIs. This is a periodic activity the wallet repeats as needed. All right, you got a new person you're interacting with, a new other friend bot on the network. That's going to be, your PFI. Basically, everybody's going to act as a PFI to each other in this situation, because we all have these unique currencies, which are the and the currency is production, right? If you're playing, like, if you're familiar with like a civilization game or something, like what we care about is production, right? um, there's no, I mean, money could be involved, right? But money is one aspect of production. Okay, so um, okay, so this is period. Okay, number two. Through the wallet user interface, Alice initiates a flow to request cryptocurrency XYZ in exchange for 100 USD. The wallet generates a semantic message that reflects an ask encoded with the parameters of Alice's request. Okay, so these wallets. So we should find one of these wallets, and um, we should build. Okay. Yeah, we should make sure that we're interoperable with these wallets. Oh, what do we got here? Great. Oh no, it's just me. God damn it. Whatever. Okay. Yeah, I posted these on. Okay, good. Saved. Okay. Um, okay. Yeah, we should make sure that we're interoperable. Okay, so wallet, I'm just going to say, remember trail. That's right. Okay. Okay, this is all to do. Why are we writing all this down? Because we're not going to ever possibly be able to do all this stuff. But as soon as Alice is able to do all this stuff, it's all going to be done. So, because we'll have the list of all the things we want, the wish list. So, the wallet sends an ask. Okay, so the wallet generates a semantic message that reflects an ask encoded with the parameters of Alice's request. We should open these side by side. Okay, we're just going to look at this now. And so now we have renamed. Have we effectively renamed Alice? Did we rename Alice? Prioritizer. No, I don't think we'd renamed. I think it's still in the, yeah, here it is. It's in the terminal. Okay. Yeah, okay. Great. So this looks renamed. Let's just give a quick, okay, yeah. %s, Bob, Alice. Okay. And then within here, we will replace Alice with PFI. Ah, I have to fix the highlighting on this, or else when we do select on these recordings, we aren't going to know. When we do select on these recordings, Alice won't know. So we're going to take the recordings of these development sessions, and we're going to feed them to Alice as training data to sort of teach her how she is built. And one of the goals would be sort of by which that we could, like, one of the ways by which we could determine this, our like a level of success on this project is to, you know, give verbal instructions on how to take the code bases as they were at the snapshot in time that we start the project, um, and then have Alice go transform, into the version which she exists as, whatever the code base looks like then, or functionally equivalent when we end the project. So basically, what we would do is, we do the whole project, and then we say, hey, Alice, redo the project, which is herself, and we will come up with, an architecture that, um, learns from all of the things that we did. So maybe as to do it better, right? Like a refactor, on an automated refactor. I think a lot of what we're going to get into is probably going to be automated refactoring, because we need to take things from like the ideation phase through to something modular, right? Like our goal is really to shoot for functions, right? As the one, like a function per file is really our goal, right? For in terms of portability and modularity, right? Because if we could do a function per file, if we could, you know, facilitate processes which would allow for representing code bases as purely one function per file, um, and the tooling around that to make that feel integrated, then everything would be sort of as modular as possible, right, and as testable as possible. And so, but also, yeah, okay, it doesn't really, okay, it doesn't really even, it doesn't really even matter because. Hmm, Yeah, it is because every file and every function becomes like this data transformation, right? And it's basically, the inputs and outputs we record, right? We know their definitions, and then the config we record, right? So we basically have, like we're creating almost this like functional programming out of not functional programming, right? So we're going to analyze all the code, and then we're going to map it into this, intermediate representation, which is our open architecture, which is our data flow, and then we're going to sort of optimize across, right? And kind of refactor and fix things across. Okay, so now I can't remember how we got here. All right, all right. All right, no more explaining. Um, oh yeah, we were talking about feeding these videos to Alice. Um, Yeah, so really it'll just be interesting because we need it to be explainable, right? And we need to be able to have this uh, arbitrary level of abstraction upon which we use to interact with Alice, right? So that we can define things by hand where we need to and write our own functions as we iterate over this activity, which will be, you know, uh, fairly complex, right? Um, and we won't have all the answers. So we're going to hand code parts of it, decision trees, et cetera, until we can figure out what the more accurate models are. Okay. Um, and we just keep iterating that loop until, the until one can successfully feed the data set of how we got to as far as we have um, to the final product, right? So basically, you know, so that would be up to speed, I guess. Okay. Well, let's not think about that now. Okay, so the PFI and Alice swapped here, and we're gonna put this on the side here, and we're gonna go back to this on-ramp example. Okay, so the PFI is Bob, and Alice is, so the PFI is submitting an, let's see, so the wallet sends the ask message to the identity hubs of each PFI. Okay, so Bob is to include as a potential fulfillment counterparty. Okay, so Bob is fulfilling the desire for this currency. And what is the currency? The currency is the execution flow, which Bob proposes as a counter proposal to the execution flow, which Alice already put out there. Right, because, and this is why it's a little bit confusing, because there's already one counter proposal that's happened here by the time we're involving tbDEX, right? So how do I draw this? We'll just do it on here. Okay, I just feel like now it's getting a little bit okay. So maybe let's just, yeah, okay. I like the highlighting helps. Okay. Okay, so Alice does the ask. We'll just work that. Okay, Alice. This is too far away. Okay. Alice prioritizer goes to ask. Okay. So new system context from external entity, create offer. Okay. So let's remove the word bid anywhere it's used, because we're overloading that term now. Because I believe, let's see, what is bid in the tbDEX notation? Yeah, we have this. Okay, we totally flipped all the terminology, which made this way more confusing than it should have been. Okay. New system context from external entity bid. Okay, let's get rid of bid everywhere. AKA bid. Okay, so let's say bid. What is what do we mean here? So the identity hub, which is Alice does the ask. The identity hub is Bob. Bob does the bid. So Bob says, yes, Alice, this is an acceptable system context for you to execute in response to my call for execution, right? So you may say, okay, so Bob may say, for example, this is where the strategic plans get interesting, right? So Bob may say, I want to deploy a service with 99.999% uptime, and I want it to cost $5 a month, right? So Alice can say, okay, I can do that, right? She can look and she can say, okay, look, I have some provenance information in the form of reviews that says, I can offer nine, whatever amount of nines of uptime, right? And so then, Bob will get that back, Bob, the identity hub, and he'll say, okay, let's see. He issues the bid, And um, then, so Bob issues the bid, right? So Alice says, yes, I can do that. Here's the ask. Um, Basically, Bob, I have X system context, right? I have currency, what is it? Target currency? Where's how did this become its own thing? Oh yeah, because, okay, fine. Target currency, source currency. So because we need string. We need a string field to plug in our DIDs. All right. So, source currency, the currency that you currently hold. Okay, yes. And so this is Alice. Alice holds what currency does she hold? Well, she holds the system context which she is able to create, right? Um, because she's creating it as a response, which is a counter response to Bob's proposed system context, right? So Alice may say, I can spin you up those 4 servers on this. Maybe we had something that we were going to use that lets you pay for servers with cryptocurrency, right? So what we could do is we could say, hey, you know, uh, let's see, what we could do is we could say, Alice could say, hey, I can spin you up these servers, but you're not going to get 9 nines of uptime. Maybe you get 4 nines of uptime, right? And so Bob, the identity hub in this case, um, where's our where's our diagram? Come on. Oh, did it? Does this where it gets rid of my mouse? Okay, so Bob, the identity hub, who unfortunately doesn't fit on the screen anymore. Okay, we're gonna have to use a little trick here. Okay, so bid, we're gonna get rid of bid. So Bob, the identity hub, comes back, yeah, and that's why we're here. So we need to get rid of this word before it confuses me again. All right, okay. We're just gonna call it, response. Okay, there we go. It's gone. This is another bad choice, but just to get us through this few seconds here. So, all right. AKA response on job. Okay, so response on job, that's not what we really want. So, create offer, response on job. Okay, new system context from external entity response. Okay, new system context from an external entity, and we're creating a response to it. So, but the response is a terrible word to use here. It's way too generic. So, new system context from external entity, um, generate proposal or something. Um, yeah, counter proposal. Um, it's a counter proposal. Yeah, it's a counter proposal, right? So what is this counter propose? Counter propose system context or proposed acceptable, proposed aligned, proposed aligned, proposed aligned system context. Because the key here is that we don't care if you do it exactly the same way. We care if you do it within acceptable guidelines, right? And so the thing is, you can't, and the reason why some of these, why transferring around some machine learning models is going to be helpful here is because, and the combination with this whole idea that tbDEX is also talking about, of like your trusted parties in this reviewing system, is you can't everybody's environment is going to be very difficult or different, right? And so you need to have this translation mechanism which allows you to say, okay, yes, this fits, this is sort of like the compliance that scales to your it's a scalable compliance, right? Scalable risk mitigation and management that's built in here, so that you can basically say, hey, whatever the scope of the problems that we're dealing with within these transactions, right, where we're trying to get stuff done, right? Basically, choose subcontract within a within subcontract and scale within my overall organizational or set of organizational risk management policies, right? And she can do that all in an automated way. Um, okay, so what do we decide? Response. So yeah, no, fuck that. Bids. Okay, quick response. Okay, we called it aligned bid. This is probably going to look bad too, but let's see what it looks like first. Okay, determines we want to wait for aligned system context before executing. Okay, that sounds a little better. Okay, so new system context from external entity, aligned system context, aligned system context analysis, aligned system context. Let's see. So new system context from external entity. So what happens? So align system context. So we go in search. So first we decide whether we care, right? Okay, you told me that you're doing something, right? Meh. Okay, I don't care. But maybe it's like I'm focused on something else. So let's take that example where we were talking about the two developers working on a project. The database service goes down, right? And they're co-developing on a feature branch, right? Each their own feature branches, but they have some cross dependent stuff that they've been cherry picking across each other's branches, right? And so when they do this, um, they sometimes developer or sometimes Alice is going to be working in um, let's give a more concrete example here. So let's give a concrete example. Hmm. Okay. Yeah, we have two services. Um, yeah, okay. So basically, remember when we remember we said the database goes down. So maybe if I'm not working on anything that's related to the database, then I don't care, right? I'm not going to, Bob may be saying, hey, the database went down, right? Like I need help, right? And that might trigger Alice to go generate a system context which says, hey, uh, notify John's phone that the database went down, and you know, uh, he needs some help right now, right? Maybe there's some kind of threshold, which Alice knows how to help some situations, and then what other ones she doesn't know how to help, she calls out, right? And so, so within that, this regular broadcast of system context, sometimes, you may have a profile set up where it's like, okay, well, within these trains of thought, right? And so, what are the trains of thought? Well, a train of thought is a classification that happens on a sequence of system contexts, right? So if you have a sequence of system context, or like the general clustering which a sequence or set of system context falls into, right? So basically, effectively, so maybe the two Johns, we're doing development work on the project, right? And we're writing some collector interfaces, and we're writing some visualizations, um, and um, and okay, and we want to we want to automatically, you know, revalidate the changes that we're doing, um, against each other's development work, right? So we want to essentially, this is like this A/B feature testing stuff. Basically, we want Alice to automatically cherry pick off each branch to generate this like matrix of permutations to understand the commits almost as if they were individual feature flags, which will feed in as inputs, right? And then we'll generate all the valid system contexts, being the ones that pass the test between our two branches, where we cherry picked across all of the individual commits, right? And this will basically tell us, what is our bleeding edge version that we're both working off of, right? And that's sort of the best known tested version with all applicable feature flags available, right, and enabled, and then everything else sort of molding to that, figuring out what other API calls need to be changed to support those feature flags. Would get into that. That would be a later thing that we would do, right? But in that case, the execution policy may be such that when you see Bob's changes come in, or well, yeah, so when you see Bob's changes come in, right, PFI1 Identity Hub, for example, says it issues, so aside from these two things, let me just get out Paint. All right, so basically, dude, okay. All right, so essentially, this would be, this let's make this like not the giant, and then let's say, okay, so uh, mid commit, right? So Bob made a commit, um, and so this would be here, right? And then so Bob, give me the brush. Bob will come over here and tell Alice, 0. Something happened, right? So something happened. System context. Bob says, Alice, something happened. Alice says, oh, Bob, I would like to help you with that. Here's how I can help you. And then Bob says, great, I would like your help with that. Here's my bid, which says, I would like this many helps of that, right? This many helpings of help, right? And then Alice goes and does it. Okay, and then they do the settlement or whatever, right? Great, glad we ironed that out. Now I wish I had that picture. Oh, we have the recording. Okay. All right. Okay. Great. I'm glad we got that figured out. Okay. Paint. Thank you, Paint. Um, Always there when you need it. Thing is the best. Okay. Um, okay. This is great. Okay. So new system context from external entity aligned system context. Okay. So new system context for external entity. Let's just leave it right there. That is the end of that sentence or phrase. Okay, so this is what's happening right here, right? So we are going to create an offer aka align system context. Okay, yeah, that is an applicable thing to say here. Create an offer by pushing or by creating a DID for a DID, yeah, creating a DID for an aligned system context, right? So we create the aligned system context, we store it off chain, we issue a DID which says, this is the aligned system context. Hey, Bob, would you like me to execute this thing, right? Um, and then and to do that aligned system context creation, determine the ability to, we determine the ability to create the valid system context. We determine the set of valid system context given the top level. So determine set of valid system context given top level system context and assets at disposal, right? So what do I have any computers? Can I actually run anything? Well, no, well then I'm not going to be offering, I'm not going to be issuing an ask. If somebody's asking me if I can help test something, right? So respond with proposed DID to be, that's a really interesting choice in line break there. I guess this is a bit of a mess of a thing anyways at this point. We should just split this up. I don't really want to split this up. It's all sort of, this is basically a subflow. Well, not really, but it's fine. It's fine for now. We could refactor it later, right? Okay, respond with proposed DID to be executed system context given as source currency. Generate the ask. Bing. Okay, so ensure content. Okay, so at that point, we jump back over to Bob, the PFI. Good old Bob, the PFI. Okay, so ensure, that's spelled wrong. PFI get aligned system context. Now that is a much, 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 much better name for an operation than get bids. Much more descriptive. Okay. PFI check on aligned system context. Okay, so prioritizer feeds into PFI get aligned system context. Check on aligned system context and timeout are all going to feed back into the prioritizer, which then will feed into get aligned system context. Okay, because everything is one level deep. So ensure system context on chain and clearly broadcast request. That shouldn't be capitalized. And clearly broadcasted. Okay, I really, I decided everything needed to be capitalized there, didn't I? Okay, none of that needs to be capitalized. Okay. Okay. Ensure system context on chain. Okay, so PFI, get aligned system context, says check on aligned system context. Okay, so get set HL search. All right, turn on the highlighting. All right, PFI get aligned system context. So PFI get aligned system context goes to ensure system context on chain. So new system context, explore outsourcing opportunities. PFI ensure context on chain. I don't like, maybe collaboration. Sourcing. Collaboration, because this is not necessarily like you might work together. You might propose a subcontext where you both share resources, right? So Alice may say, or Bob may say, I have this, I would like to get this thing done. And Alice may say, hey, I queried your inventory of available machines for jobs like this, and it says that you have this many job or this many runners that you could be using to help with this job. And Bob says, oh, hey, great, gee, thanks, right? I didn't know that because I just issued the request for the system context to be executed, right? Bob didn't go check. He didn't go check he's checked the validity of the system context before he submitted it, right? He didn't check the provenance information all the way through, right? So Alice goes, she does the due diligence, right? And then she submits it back to Bob, and Bob says, okay, looks like you did your due diligence. Looks like everybody who I trust signed off on your due diligence, right? Basically, let's go. Here you go. Here you go. I accept, right? And in that case, um, then um, then we go execute. Um, so let's look at the tbDEX thing. So I offer, accept, IDB request, IDB submission, settlement request, settlement details, settlement receipt. Okay, so okay, let's go back to the white paper. Okay, okay, here's what we're gonna do. We're gonna dump this. Um, we can use a little trick um, on the tricks page of the blog, which is basically if you do echo and then you just give it the HTTP headers. So like, let's just do 1.0. I can't remember if it's backslash or forward slash. I think it's backslash. HTTP backslash 1.0 200. Okay, quite honestly, I'm not even sure if it matters. I think it'll eat the headers either way. Then give it 2 new lines, or give it 1 new line, because Echo will add the other new line. And then give it a cat, whatever your file is, and then pipe that through netcat. And netcat, listen on something like 8,000. And now we can just hit localhost, and it should dump our file. Unless that backslash should be a forward slash. Oh, wait a minute. 100. That's not what we're looking for. 200. Oh, there it is. All right, might have come through anyways. Or no, it did grab it again. Okay, so that's a little trick of your terminal. Like if you're running tmux, it doesn't copy paste easily, essentially. All right, let's regenerate. All right, wow, it's gotten more complicated. Great. I can't see any of this. This is way too small. So let's see. Okay. Now with the SVG link. All right, now we can zoom. Ah, SVG. Fantastic. Okay. No loss. Okay. Code every input to DID. Okay. Conditional offer. Okay. Uh-oh. Everything is Alice. I think something happened in the tbDEX flow. Alice is doing everything. This is a problem. Let's go recopy paste from the tbDEX doc. State machine diagram. We can't have that. Okay. Okay, and here's what we can do. Check. So we can run nodemon, and then we can just say on markdown file change, clear the terminal, pipe through netcat, and then test one. I always add test one at the end, or else nodemon will be unhappy if sometimes it doesn't, if it fails sometimes. Okay, it's not happy, but the quotes. Okay, let's put this in single quotes or double quotes on the outside. All right, so great. So now we can basically just um, where did it go? We can hit this URL as many times as we please. Although I think we should run ncat with that n. This should be in a while true. While test1 do blank, add a little sleep at the end here. That way we can kill it. All right, cool. So you see how it's loading at the top of the page here, and then it stops. That says the connection's closed. So over here, yeah, we should have a series of connections. Perfect. Okay, this is going on this is a good one. Oh man, that's great. Okay. Where is it? I think it's on here. So now we're updating our notes, basically. This is a generic note stock, and here it is. So display a file as plain text in the browser. So console, so this would be redisplay on reload. And then we'll put a note here that dash capital N to netcat means close socket on EOF from stdin from standard input. Great. Let's see, is it there? Yep, looks good. Okay, we'll leave this open. All right, now we can just go copy paste. Okay, let's do another thing here. So when we see space aligned system context, let's go ahead and replace that with just space, because I see several places where this should bid would have not been a variable name, so aligned system context. All right, so yeah, here, here, here. All right, great. Now that looks better, right? So the non-variable names, the ones where spaces are not sensitive. So, okay, so ensure, so Bob, the PFI, ensures system context on chain, clearly broadcasts request for align system context to chain, right? So he's doing call for proposals. Give me your align system context. Alice goes down and she says, hi, Bob. Here's a new system context from external entity. Let me create an offer by creating a DID for an aligned system context. Let me determine the set of valid system contexts given the top level context and assets at disposal, and then respond with the proposed DID of the executed system context given as the source currency with provenance information. Let's say determine respond. So ensure provenance information / reviews submitted upfront with aligned system context ask. All right. So new system context from external entity. Create offer by creating determine set of valid system context given top level system context and assets at disposal. Ensure provenance information / reviews submitted up front with line system context as ask proposal for acceptable execution of aligned system context. Execution or hypothesis. Okay, so execution, and I think there might be another one here. I think it's execution, remembrance, which I'm not sure if that's a word, but it could be, or hypothesis. And so basically, remembrance would be pulling information out of uh, the memory of an entity. Just please remember something for me. Please give me this data. Basically, cached execution, right? So what we're going to do is we're going to go ahead and make GraphQL. Um, we're basically going to we can overlay using our output methods, and we'll basically in our cached execution we'll basically overlay a GraphQL endpoint system on top of the cached executions, and we can blow, like we talked about, sort of blowing something up. Like we'll get rid of cached entries where we want to do re-execution by simply requesting a different GraphQL node type, and that GraphQL node type will just be a orchestrator, which will basically be a system context backed by an orchestrator, which is not based on the caching stuff. But if you wanted to do caching within that one somewhere, then you could. So you can basically get rid of whatever you need to, right? And so you can query, the state of your network, and well, what is the state of your network going to be, right? Effectively, what we'll do is say, um, you know, what is, for example, my what is my organization's? We're all working on a code base. What is the bleeding edge version, right? So what's the one that has all the feature flags that we've, tested together across all of the CI jobs and all of the functional and all of the fuzz and all of the things that Alice came up with external to all of that, right? In terms of, measuring KPIs or whatever to determine what other things, what other tests really should we be running these things through. Um, you basically what you're saying is uh, you're running that query on a continuous basis, and you're saying feed me more results as it happens, right? And then publish that, right? So, well, how can you do that? Um, um, well, you basically you let's see. Well, let's see. Yeah, so you overlay the cache flows, and then you probably have different things updating the caches every so often. So you have the cache flow on bring up to do the immediate query, and then you have the on-demand execution, which is fed by subflows within there that are running in the background, probably to repopulate the cache. Interesting. Yeah, okay. I don't think that's fully ironed out, obviously, but whatever. Okay, so given a source currency, um, and then that generates the ask. Okay, so execute. So we create this offer by creating a DID for a line system context, right? So that's the ask. And then let's look at the tbDEX diagram. Oh, that's right. We screwed up. We have to go recopy paste from them. Yeah, that's all Alice. All right, I think I might have left some tabs in there. No, okay. Because we were in paste mode. All right, PFI, Alice, Alice, PFI. Okay, let's reload. Here. Wait for it to stop. Alice, 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 Alice. They're all Alice. Shouldn't you be serving us a page? Okay, yeah, there it is. Okay, I hard reloaded this time and it worked. So must have had a stale keep alive, maybe? I don't know. Okay. No, something's broken. It won't regenerate. It must be in what we just wrote here. Yeah, something on this line. Ah, there it is. Okay. It didn't like this character. You can HTML encode these, which we'll do. Looks like, yeah, okay, it took. Why won't it do the SVG? Probably because it's too big, the URL gets too long. Do not open that with Edge. If you open that with Edge, I will be pissed. Let's see. Okay. Yeah, nice line break. Not okay. So the PFI, or wait, no, Alice issues the ask. Should have Alice on the left here. Alice, yes, Alice creates this aligned system context, puts the DID of the to be executed aligned system context. That should say aligned system context. Okay. DID of the line system context given as source currency. Bingo. All right, let's go back and check the white paper. Okay, let's get rid of this stuff. We don't need this right now. I think we know where to find. No, let's leave the DID course back open. And let's go back to the tbDEX white paper. Okay, we need to keep that open now. Okay. Okay, so interested PFI responds to the ask it receives with a list of bids. So the wallet sends the ask information to the identity hubs of each PFI it desires to include as potential fulfillment counterparty. Okay. So we're saying Bob, can we execute this system context? Is this aligned? Bob says, sure, Alice, that's aligned. And within that system context, we may include some information, right? Because we are specifying contracts to be executed, right? On, you know, we're specifying contract. We're going to put contracts into the chain, right, to be executed off chain and on chain, right? And we're going to say, um, part of that contract is Bob pays Alice to do this, right? So Alice says, I propose that I'm going to, spin up on cloud provider XYZ and whatever, right? And this will get what you want done, Bob. And Bob will say, okay, great. Now, in that proposal, you should have included for me, all of the things that I told you about, hey, these are acceptable system contexts. These are the strategic plans, right? Which I'm going to vet these system contexts with. Ding, 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 ding. That's the next thing we need to write down. Okay, so Bob, where are we, Bob? Bob the PFI. Okay, so PFI operation prioritizer check the line system context trigger. Okay, so trigger timeout goes to trigger, trigger goes to check align system context. Okay, if time is off, up or good enough offer, threshold met, conditional offer. Okay, so the okay, so strategic plans. He found a little warm thing. Yay. Strategic plans. So why is it important that we put that Alice go on chain, right? Is because to facilitate this trading, right, of arbitrary resources, we need to have the ability to map one person's understanding to the other person's understanding so as to come up with a valid aligned context, right? Because I really have no idea what the hell you consider to be a okay way to spin up three servers, right? If to you spinning up three servers means because of your particular situation means you need them in a bunker somewhere, right? And you need like one line in that somebody is like, waiting with a axe next to chop, then that's going to be different than, a different fulfillment than someone who says, let me just run that on QEMU for you at this Raspberry Pi that I left in a coffee shop, right? The different level of security assurance involved there. And so, these are things that we're going to need to understand as we create our bids, so that as we create our asks, um, because we need to know, whether we should even bother, submitting an ask for this job, or an ask to be rewarded for a aligned job. That's what we're doing. We're submitting an ask to be rewarded for an aligned job. So within our tbDEX usage, we are submitting asks to be rewarded for aligned system context, remembrance, hypothesis, or execution. And it's basically all execution, right? But there's a couple different sort of levels of, sort of read. There's read, infer, read, write, sort of, right? Right. They all boil down to execute, but within a different sort of sandboxed. They all really mean execute some architecture, maybe a data flow. They all really mean execute some architecture, maybe a data flow, which might include something which would allow for scoped sandbox execution. At given privilege, or two given constraints. That is one of the things that I think we were forgetting within the system context. So constraints are important. Constraints are part of the strategic plans. So constraints are part of the strategic plans Constraints are part of the strategic plans. Constraints are part of the strategic plans, which would result in a dropped system context from the gatekeeper, right? So if this thing is a binary yes, no on am I going to execute this, that's a constraint, right? Constraints exist as a concept which is implemented via a strategic plan, which constraints exist as a concept which are implemented via strategic plans, which strategic plans which result in a dropped system context are. Constraints exist as a context which are implemented to strategic plans which result in a drop system context by the gatekeeper are called restraints. It would be interesting if we could move away from saying something is called something towards saying this is something something more generic, more abstract that says this is, I mean, we're writing, but the English language, one tag associated sort of do like a association conceptually, right? And say, the most aligned conceptually. So basically, called restraints means, within the English language, the best used, the most closely aligned word for the description, which is these notes, right, organized in this manner. Word that we should use is restraints because that is the most conceptually similar word to what is happening functionally. And how would we tell that? Well, the gatekeeper. So the gatekeeper will or will not consider executing something based on whether certain outputs from the strategic plan are part of the go no go list defined within the gatekeeper's config. These things, how would we have Alice know that constraints, or sorry, constraints are called constraints. So how would we have Alice know that the right word is constraints? So, constraints. So, how would we do that? Well, let's look up define constraints. State of being restricted or confined within prescribed bounds. One that limits, restricts, a check. Okay. Necessity. Constraint may not be, this is not, design constraint. Design constraint would be the correct word, probably. Conditions that need to happen for a project to be successful. Design constraints are conditions. So in this case, are called design constraints. And then we can put our little quote here with our link. And I'm not going to think of any more right now. But if you want to think any more about how we might have Alice understand that she should describe using the word design constraints, that would be great. Okay, so, and we'll just say, reworded true. Okay. All right, let's jump back to Mermaid. Okay, let's copy paste this over while we're at it. So I think we made progress, and I don't want us to lose this. Bob the PFI. Oh, because I double mermaided it. Okay, yeah. Oh no, because I. Okay, there we go. Okay, yeah. Okay. Align system context. Okay, that's the right version. All right. So let's give ourselves a little breathing room here. Doesn't help. View. Okay, so PFI Alice. Okay, I need to look at the tbDEX one. Okay, so Alice. Okay, so ask PFI conditional offer Alice. So Alice submits the ask. The PFI submits the conditional offer. Alice accepts, right? So Bob says, okay, that sounds acceptable to me. So Alice says, Bob, I would like to help you by doing this aligned system context, which may be not exactly what you wanted, but I think is pretty much still pushing the strategic principles you were looking for. And how is she going to know that? Well, because Bob is going to include the strategic plans and the models and references to them via DID documents, which were created by encoding the system context into a chain of DIDs via peer DIDs. Right, so Alice is going to have the information she needs to run the models to tell her, what are basically to run through the strategic plans. So we're going to give Alice the strategic plans in the form of the system context, in the form of an open architecture spec, in the form of a data flow, which she can go run to help her determine whether the valid system context which she's thinking up are aligned with Bob's strategic principles, right? And whether that they would be acceptable for the execution of this context specifically as an acceptable, sort of either verbatim the same thing or replacement. Or just, maybe, hey, noticed you're working on something, I'm working on something. If we both could share a server, hey, based on the uptime of our other interactions, we can add this asset to our pool, and we project that may be, help us in the future on other jobs, right? That could be okay. That was a whole another thing, but that was basically you could apply that as another strategic plan, which goes and looks for these opportunities based on other assets out there. What are you doing? Are you gonna go pee over there? I'm watching you. I know you tried to pee over there the other day. All right. Okay, so IDV request. Apples. IDV request. So PFI IDV request. So Bob comes back. Don't know what IDV request means. IDV request. And I can't control F. Okay, finish reading this. Interested PFI responds to the ask it receives with a list of bids. So Alice does the ask. PFI responds to the list of bids. The PFI has the liberty to choose which credential types they require for a given bid, right? Um, it is possible for the PFI to offer a bid with no credential requirements, given that each additional VC presumably reduces the risk taken by the PFI. So we are basically, so they're saying that, the PFI should come up with provenance information, right? So what we're saying is basically, we're going to come up with that for you, right? I'm asking you if I can do the job, right? So I'm going to go figure out your provenance information for you because I'm going to figure out whether you can pay me or not, right? Before I even submit this job back, right? So the first thing I'm going to do is, hey, this person's submitting a call for aligned jobs, right? Is this even something that's worth me looking? Where'd you go, dude? Okay, so yeah, so we're basically saying, hey, let's do this up front, right? Because we don't want to go and do any more work. So basically, we're going to do an initial gate that says, hey, do I even know you, right? Do I even care about offering an aligned context? Maybe you're some kind of crazy, you know, uh, you know, person who's trying to get me to spin all my CPU cycles, creating aligned context, right? So I'm just going to drop those packets, right? I'm going to say I don't care, right? So for those people who I do care about creating aligned context for, right, or just these aligned contexts that's come in, right? I'm going to say, I'm going to say, well, okay, so in that check of do I want to do it at all, I'm going to say, well, does this, you know, is there something here? Let's see. So what is PFI has liberty to choose which credential types they require for a given bid. It is possible for the PFI to offer a bid with no credential requirements, given that each additional VC verified credential presumably reduces the bid taken by the PFI. It's likely the PFI will provide better rates or speeds for bids with higher levels of credential requirements. Any choice for PFI response to the ask. A list of bids. What's a bid? Ask. This is provided by the PFI and may discoverable through the PFI's DID. Okay. The PFI receives an ask from a wallet. It will decide if it wants to offer a bid based on the details of the ask. PFIs are not required to support all possible schemes and asks. Ruffles, Ruffles, stay here. Um, for example, some PFIs may accept credit cards while others may not. The tbDEX protocol may carry information that enables PFIs to decide whether they seek to bid for the wallet's business, and if so, what VCs to ask of wallets. The protocol will also carry the required regulatory querying information required by PFIs to conduct their AML and KYC, I don't know what that is, checks before the provisioning liquidity to the wallet owner. However, necessary information may vary based on jurisdiction. To participate in the network, PFIs will run nodes that facilitate the reception of asks and transmission of bids. Conceptually, PFI nodes are similar to wallets and will rely on the same underlying modules and library. The tbDEX protocol does not execute fiat or cryptocurrency transactions. This is provided by the PFI and made discoverable through the PFI's DID. Yes, precisely. So this is, for negotiating, right? And so the actual execution is what we're doing of like, we're just going to execute whatever data flow, right? We don't care about what is in it, right? If what is in it says, hey, we're going to go, um, you know, if what is in it says we're going to go, spin you up 3 servers on QEMU, then great, right? It doesn't have to be, I want cryptocurrency, send it to me, right? It can be do whatever you want. And that's the point of what we're using tbDEX for, is to agree on what, hey, you told me you want to do something, or you told me you want something, right? I told you I can offer this to you. It's aligned with your desires, right? You say, okay, I accept, right? Which is this. Alice picks one of the bids by responding to the original signed hash of that bid, along with a presentation of credentials required by that bid. Alice picks one of the bids by responding to the original signed hash of the bid, along with a presentation of the credentials required by that bid. Okay, so this is interesting. So Alice picks one of the bids by responding. So the PFI is Bob, right? And so Bob's going to say, Alice picks one of the bids by responding to the original signed hash of that bid, along with a presentation of the credentials required by that bid. Okay, so presentation of the credentials required by that bid. I think we're including those up front because we're just going to say, you know, you're not even going to consider because Bob is the PFI and Bob has already made an offer at this point. So, or he's already put it out there and said, you know, hey, I'm looking for people to execute aligned context, right? So we better be ready to rock and roll by the time we get back. We don't want to make another hop here to do VC lookup. We should include that up front. So, along with the presentation of the credentials. So we're not going to worry about that. PFI verifies Alice's presentation along with the credentials within that presentation. If everything checks out, sends a final bid to Alice. Okay, so basically we're going to skip. Okay, so maybe that's IDV. Alice accepts the bid by signing it and send it back to the PFI. The PFI publishes a smart contract to the blockchain and funds it to establish proof of ability to settle with the agreed upon amount of XYZ cryptocurrency and sends the transaction address to Alice. Alice's wallet queries the contract to ensure the agreed upon amount is present. Alice's wallet then fetches the accepted means of payment from the PFI's hub. This means the payment will be exposed as individual services. Alice selects her preferred means of payment from the ones available. Alice's wallet facilitates payment through the service associated with the selected means of payment. Once the PFI is happy with the state of the payment settles, they execute the smart contract to release the crypto to Alice's wallet address. Okay, so this basically means Alice is buying crypto, right? And so Alice is submitting an aligned contract and she wants to be rewarded, right? The reward from Bob may come in the form of crypto, right? It may come somehow else, right? So send funds in this example, right? So PFI1 is Bob, or let's see, no. PFI2 is Bob, right? And we're going to do this verify credentials in here, up here, right? Because Alice is going to do the ask with the credentials, and we're gonna have them be basically the credentials are going to come through with the ask, right? Do I have the required credits? So which bit is best? Okay. Yeah, no, okay, so we're going to do the ask. Okay, so we can keep it split like this. No, that's probably good because we don't want to give up way too much information. So we could probably have either flow. We could probably support either flow. So do I have the required creds? Decide which bid is best. Disclose the creds, Alice. Yes. Here are the credentials you asked for. Verify credentials. Here's my bid. Accept this bid. Yes. Okay, I accept your bid and then create transaction on the blockchain. Okay, so this basically says, hey, you know, the money's out there, right? We can prove that the money's out there, right? So this is, you know, publish. This is not for the blockchain. This is not up. Right? It's us. So okay, so I accept your bid. So where's that? I don't know what IDV means. Maybe this is more applicable to us. Ask. So Alice's wallet resolves and caches the current set of keys and data to the wallet. Alice initiates a flow to request currency, in this case USD, in exchange for 100 units of cryptocurrency XYZ. So basically, Alice initiates a flow to request, one system context or one, let's see. Alice is requesting that Bob accept this as a, let's see. Alice is requesting, Alice initiates a flow to request her own execution. Yeah, she's initiating a flow to she's initiating a flow to propose that she execute a line system context in exchange for something. Alice's wallet generates a semantic message that reflects an ask encoded with the parameters of Alice's request. Alice's wallet sends the ask message to the identity hubs of each PFI to each Bob it desires to include as a fulfillment counterparty. An interested PFI responds to the ask and receives with a list of bids. Alice picks one of the bids by responding with the original signed hash of that bid, along with the presentation of the credentials required by that bid. PFI verifies Alice's presentation along with the credentials within the presentation, and if everything checks out, sends a final bid to Alice. Interest. Okay. PFI verifies Alice's presentation along with the credentials within that presentation, and if everything checks out, sends final bid to Alice. Alice accepts the bid by signing it and sending it back to the PFI. Okay, so let's map that to this. Okay. The wallet creates a smart contract and funds it with, by signing it and sending it back to the wallet creates a smart contract and funding it with 100 units of cryptocurrency and sends the contract address to the PFI. Oh. So Alice is going to put the cryptocurrency out there. Create a smart. Pull the funds into the wallet. Create a smart contract. Okay. So Alice creates a smart contract and funds it with 100 units. Okay, Alice creates a smart contract and funds it with 100 units of cryptocurrency. Sends the contract address to the PFI. PFI queries the smart contract to ensure that the agreed upon amount of XYZ is present and then initiates a transaction to pull the funds into their wallet. The PFI pushes the agreed upon amount into the destination provided by Alice. Okay, I don't think we even care about any of that. Basically, Alice accepts the bid by signing it and sending it back to the PFI because we don't care about money. We're just doing stuff. Accepts the bid by signing it and sending it back to the PFI. With the credentials, and so one of the things that you do could be this, right? PFI verifies the presentation along with the credentials within the presentation and sends a final bid to Alice. Alice accepts the bid by sending it back to the PFI. Offer accept. I do view request. Okay, so maybe this is the checking. This is probably the checking if I do request. This is like put the money in the blockchain, check the money in the blockchain, do the settlement, PFI, go change hands with the real money, and then settlement details, and then basically the PFI. I don't understand this. I don't think we care. Offer accept. Ask conditional offer. Offer accept. Settlement receipt. Okay. Yeah, well, we can't really do any of this right now. Conditional offer. Source currency. Okay, so source currency is the thing that I'm willing to give you. Conditional offer is the thing that I'm willing to give you for it. So basically we say, here's the aligned system context. Conditional offer says, here's what I'm willing to give you for it. Source currency is different. Okay, I think I missed that. So the ask. Okay, so customer comes in. So Alice comes in. She says, this is the thing I can give you. And here's the amount I can give you. And here's, so Bob comes in and he says, here's the thing I have. And then you currently hold the currency that you want. All right. Currency that you currently hold. The amount that you currently hold. Why is there no example? Let's go look at the code.